Hi, in this video we'll be covering chapter 11.2 on series and a few ways to know if series are convergent or divergent. Being comfortable with the difference between sequences and series can save you a few points, as I know firsthand that a common mistake on quizzes and tests is that teachers often ask if the sequence is divergent or convergent as well as the series. They are not the same, so be sure to read the question carefully and be comfortable with the differences. First, let's talk about the divergence test. This is a simple test, and it is usually the first thing I try when approaching these problems. The divergence test states that if the limit as n approaches infinity of a sub n does not equal 0 or does not exist, then the series is divergent. If it does equal 0, the series isn't necessarily convergent though, and the test is inconclusive. Let's do a practice problem with this test. Alright, so the problem asks us to determine whether the series 11n over 18n plus 1 is convergent or divergent. So let's do the divergence test to find out. So we'll do the limit as n goes to infinity of 11n over 18n plus 1. And the way you do these problems, just like that, and you get limit as n goes to infinity of 11 over 18 plus 1 over n, which just equals 11 over 18, which is not equal to 0, which means that the series, therefore, the series 11n over 18n plus 1, just forgot my signs there, is divergent by the divergence test. Alright, let's move on to geometric series. The basic form of a geometric series is the summation a times r to the n minus 1, where a represents the first term of the sequence and r is the common ratio. Each term is obtained by multiplying the preceding one by the common ratio. The geometric series test states that a geometric series is convergent if the absolute value of r is less than 1. You can calculate what the convergence series actually sums to using the formula. The summation a times r to the n minus 1 equals a over 1 minus r. If the absolute value of r is greater than or equal to 1, then the geometric series is divergent. This makes sense because if you continuously multiply by a number greater than or equal to 1, the numbers will either stay the same or get larger. So when you sum them, you are bound to approach infinity. Conversely, if you multiply by a number less than 1 and add the terms, you will approach a finite number and have a convergent series. Let's do a couple practice problems with the geometric series test. So the problem tells you to state whether the series is divergent or convergent and to find the sum if possible. So you have the series negative 7 to the n minus 1 over 8 to the n. And I quickly noticed that this can be manipulated into the basic geometric series form. So to do that, I pull out a 1/8. So that equals the series 1/8 over negative 7 over 8 all to the n minus 1. 1/8 becomes my a, or first term, and negative 7/8 is my common ratio. So the absolute value of negative 7/8 is less than 1, so the series is convergent by the geometric series test. We can go on to find the value of the sum by plugging it into the formula above that formula. So 1/8 over 1 minus negative 7/8 equals 1/8 over 15/8, which equals 1 over 15. And that's your answer. A common mistake on problems like this is not realizing that this can be manipulated into the form of a geometric series. We are stating whether the series is convergent or divergent and finding the sum if possible. So you have to be aware that this fraction can be separated so that it is the sum of two convergent geometric series. We should always be on the lookout to see if we can manipulate something into geometric series because the test is relatively easy. So I'm going to start this problem by separating the series into two fractions. So that will be the series 1 over 11 to the n plus 7n to the 11 over n. And at this point you have to understand that as n approaches infinity, 1 is the same as 1 to the n. So for form's sake, you can add an n here. So now you can sort of see how this is looking like the sum of two convergent geometric series. So I'll write it in a more clear way in the next step. So you have the series. I'm going to pull out a 1/11th here. So that becomes 1/11th times 1/11th to the n minus 1 plus the series. Doing the same thing here, 7/11ths times 7/11ths to the n minus 1. Alright, now it's just two convergent geometric series, and you can write out that both of them converge because the absolute value of 1/11ths is less than 1, and the absolute value of 7/11ths is less than 1. Therefore, both series converge by the geometric series test. You can go on to find the actual sum by plugging into the a's and the r's into the formulas and then adding them. So for the first part, the a is 1/11th. It's 1/11th over 1 minus 1/11th plus this series, which the a is 7/11ths over 1 minus 7/11ths. And when you work that out, it comes out to 37 over 20, our final answer. The last method of testing we're looking at is called the telescoping series. If there is a problem where the form of the series cannot be manipulated to get a clear geometric series, and the divergence test comes out inconclusive, then you may be able to use partial fraction decomposition, write out part of the sequence, and see what cancels. I'll go through the next problem step by step, showing you the ins and outs of telescoping series. First, I'll mentally try the divergence test. As n goes to infinity, 3 over n squared plus 5n plus 4 goes to 0. The test is therefore inconclusive. I recognize that the denominator can be factored into n plus 1 times n plus 4, and using partial fraction decomposition, I found that 3 over n squared plus 5n plus 4 is equal to 1 over n plus 1 minus 1 over n plus 4. It is important to notice that the difference between the n plus 1 and the n plus 4 is 3. That is the amount of terms that you'll have to add at the end of the problem. So I'm just going to write out the series or the partial sums. So when you plug in n equals 1, you get 1 over 2 minus 1 over 5. And you add, when you plug in 2, you get 1 over 3 minus 1 over 6, and so on. At the end, I wrote out the last three terms in terms of n because n is going to infinity. When I write out the limit, the terms with n in the denominator go to 0, and we are left with 1/2 plus 1/3 plus 1/4, which comes out to 13/12. Thanks for watching.